Hello guys, welcome to another video. In today's class, we're talking about fluid mechanics. Basically, we're talking about the introduction of fluid mechanics and all we need to know in fluid mechanics. Fluid mechanics is a branch of engineering science that deals with the study of the property of fluid under rest and in motion. Right? Of course, as the name implies, fluid mechanics, we have basically three parts of fluid mechanics, meaning fluid mechanics is subdivided into three parts. We have the statics, we have the dynamics, and we have the kinematic. Right? For statics, what does statics mean? Statics is the study of the property of fluid when the fluid is at rest. Also know that we have aerostatics and we have the hydrostatics. The two major things that differentiate between hydrostatics and aerostatics are the compressible liquid gas or incompressible liquid gas. Then for kinematics, kinematic is the study of the property of fluid in motion, such as the velocity and the acceleration, without considering the forces causing the motion. Whereas dynamic is the study of property of fluid in motion, considering the forces causing the motion. Keyword from those definitions between dynamic and kinematics. For kinematics, we are not considering the force that causes the motion of the fluid, whereas dynamics, we are considering the force that causes the motion of the fluid. Then, what is fluid? Fluid is any substance that continuously deforms under the application of external shearing stresses. We have different types of fluid: the real fluid, ideal fluid, Newtonian fluid, non-Newtonian fluid, and we have the plastic fluid. For the first two, the ideal fluid and real fluid. Ideal fluid, this is the type of fluid that has no surface tension and viscosity, whereas real fluid, this is the type of fluid that has surface tension and viscosity. Though in real life, such fluid doesn't exist, meaning it is hypothetical. In real life, it doesn't exist. Even water has little surface tension and viscosity. Alright, in the study of fluid mechanics, there are some terms we need to be familiar with. Let's say the properties in general. These terms are what we'll be referencing back to. They are the rudiments when it comes to fluid mechanics. The first one is the density. Density is denoted rho. This is how you symbolize your density. And what is density? Density is the ratio of mass to volume. Rho is equals to mass over volume. What is the unit for mass? Kg, right? Then volume, meter cube. So therefore, your density has its unit to be kg per meter cube. Number two, we have the specific gravity. What is specific gravity? Specific gravity is the ratio of specific weight of liquid divided by specific weight of water. Specific gravity it is the ratio of specific liquid divided by specific weight of water. Okay, let's do it this way. Specific gravity is equal to specific liquid over specific weight of water. Note, specific weight of water has a constant value. For sake of calculation, specific weight of water is equals to 9.81 kilonewton per meter cube, or 9,800 newton per meter cube. This is number 2. Number 3, we have the specific weight. Specific weight is equals to specific weight of liquid divided by volume. Okay, let's denote it. Specific weight, W, is equals to specific weight of liquid divided by volume. Recall from here, weight is equals to mass times acceleration due to gravity. Call this equation 1. From equation 1, come back to density. From density, we know that density is equals to mass divided by volume. Call this equation 2. From equation 2, make mass the subject of the formula, meaning mass is equals to density. Mass is equals to density times volume. Call this equation 3. By the time you cross multiply, we have equation 3. Substitute the value of equation 3 into equation 1. We are saying that weight, which is equals to mass times G, from equation 1, implies that weight is equals to the specific weight of liquid is equals to, by the time you substitute equation 3 into equation 1, and anywhere I see mass, substitute equation 3, you have density times volume times gravity. Call this equation 4. Right? Back to the formula that says that specific weight is equals to specific weight of liquid divided by volume. Then from here, specific weight, which is equals to specific weight of liquid divided by volume, implies, substitute equation 4 as specific weight, density times volume times acceleration due to gravity divided by volume. Observe, volume cancel volume, meaning that specific weight is equals to specific weight of liquid divided by volume, which is equals to density times gravity. Call this equation 5. So from number 3, from the property 3, which is specific weight, we said that specific weight by formula, it is the ratio of specific weight of liquid to volume, right? This is it here. Now, recall, what is weight? Weight of liquid is equals to mass times acceleration due to gravity. Call this equation 1. From here, we know that density is equals to mass over volume. Call this equation 2. From equation 2, make mass the subject of the formula. We have equation 3, right? Now, substitute equation 3 into equation 1. Meaning equation 3, anywhere you see mass, density times volume times the gravity, we have equation 4. Now, back to this property 3, which is specific weight is equals to specific weight of liquid divided by volume. Input, then you have this. Observe, volume cancel volume, then you have this. So what we are saying in essence is that your specific weight has its formula to be this, and it's still the same thing as this. Alright, property 4, we have specific volume. Specific volume. Your specific volume is the ratio of, it is the reciprocal of density. Reciprocal of density, meaning volume divided by mass as meter cube per kg, which implies 1 over density. If density is equals to mass over volume, then I'm saying specific volume is volume over mass, meaning the reciprocal of density. So in calculation, you might not be giving volume, neither mass, but since you know the density and question says that you should calculate specific volume, quickly you take the reciprocal of the density, then you get your answer. So that's it. Example 1. Question says, calculate the specific weight, specific mass, specific volume, and specific gravity of a liquid having its volume to be 6 meter cube and weight of the liquid to be 44 kilonewton. First thing first, whenever you are given a question, your task is to understand what the question says, right? Now, from here, recall, what is the formula for specific weight? Under the property we highlighted earlier, property 3, which is this: specific weight is equal to specific weight of liquid divided by volume, right? Now from here, specific weight is equals to specific weight of liquid divided by volume. Substitute. What is your specific weight of liquid? You are given to be 44 kilonewton. So therefore, specific weight is equals to 44. You can decide to convert Newton or use it in kilonewton. Okay, 44 divided by all your volume 6, and this is 7.333 kilonewton. That's question 1. Question 2, we are told to calculate question 2, specific mass or density. Take note, specific mass is still the same thing as density. So from here, what you just need to do is to recall the formula for density. And the formula for density says that density rho is equals to mass over volume. Call this 1. But observe, from the given question, we know the volume, right? Then we are not giving mass. Then how do I go about this? What it means is that for this particular question, this formula for density we know. All you need to do is to recall from property 3, specific weight is equals to density times gravity, right? We proved it earlier. So from here, make density the subject of the formula. Call this 2. From 2, make density the subject of the formula. What it means is that density is equals to specific weight divided by gravity. Now the question is, what is your specific weight and what is your gravity? From here, you've calculated your specific weight to be 7.333. Substitute, meaning 7.333 divided by, what is G? G is acceleration due to gravity, is a constant value. The G we know was 10, but now it has changed, 9.81. Any G you'll be using henceforth should be 9.81, right? Take G to be 9.84, that's what we are saying in essence. 9.81. Then divide. What do you have? 747.5. What's the unit for density? Mass over volume, kg per meter cube. Kg per meter cube. Confirm. Let's confirm. Alright, from here, the third question, specific volume. Your specific volume, what specific volume? We said specific volume is the ratio of mass to volume, right? Same thing applicable. Since we are not giving mass, find the alternative formula to use. Also know that your specific volume is equals to the reciprocal of density. This is question 3. Number 3 question. Specific volume is the reciprocal of density. Having known the value of density to be 747.5, so therefore 1 divided by 747.5, and that's 0.134. What will be the unit? The reciprocal of density. If density is kg per meter cube, then the reciprocal, that's meter cube per kg. Then question 4, specific gravity. Specific gravity, okay, specific gravity S is equals to specific weight of liquid divided by specific weight of water. What specific weight of liquid? We've calculated it earlier to be 7.33 kilonewton. 7.333 kilonewton. Specific weight of water is a constant value, and that's 9.81 kilonewton per meter cube. So therefore, the ratio of this will give us our specific gravity. Specific gravity S is equals to 7.333 divided by 9.81, and this is equals to 0.747. So this comes to the end of example 1. Example 2. Question says calculate the density, specific volume, and the specific weight of the liquid whose specific gravity is given to be 0.85. Solution. First thing first, when it comes to question, you need to understand your parameters, how to relate the formulas. Okay, let's get into it. From here, we are given specific gravity. Recall, specific gravity S, recall, specific gravity X is equals to specific liquid, right? Specific weight of liquid divided by specific weight of water. From here, specific weight of water is a constant value, and that's 9810 Newton per meter cube. So therefore, you know the specific weight of water and you know the specific gravity given, and that's 0.85. So from what it means is that you can calculate the specific weight of liquid, which is which you are told to calculate from the given question. Meaning, from equation 1, we have specific weight of liquid to be specific gravity times specific weight of water, and this is equals to, this implies 0.85 times 9810 equals to 8338.5 Newton per meter cube, and this is your specific weight of the liquid. Alright, moving on. The question told us to calculate the density as well as the specific volume. Recall, what is the formula for density? What we know is that density is equals to mass over volume. But here, we don't know the mass, neither the volume. Hence, think about another formula, another alternative for density. And from specific weight of liquid equals to density times gravity. Call this equation 2. Make density the subject of the formula, meaning density is equals to specific weight of liquid divided by gravity. We've obtained the value for specific weight, meaning 8338.5 divided by, what is the value for G? Acceleration G is gravity. Take your G to be 9.81. 9.81. So therefore, your density is equals to, what will be the value of your density? Divide this. What's the ratio? That's 850. What will be the unit for density? Mass over volume, meaning kg per meter cube. Then you are done with that question. We are told to calculate the specific volume. What's the formula for specific volume? Specific volume is equals to the ratio, is equals to the specific volume is the reciprocal of density, right? Since we know density to be 850, then what will be specific volume? That simply means 1 divided by 850, and that will give you your value to be what? 0.00174 meter cube per kg. Then you come to the end of that question. So whenever you are given a question, your first task is to understand what the parameters are, recall formula, necessary formula, then implement, then you are good to go. All right, the next thing is to talk about viscosity.